Did you know that China's Tianzhou-8 cargo spacecraft can carry up to 7.4 tons of supplies, making it the highest payload capacity cargo ship in the world? This surpasses the US Dragon's maximum of 6 tons, setting a new standard in space logistics and supply capabilities. The Tianzhou-8 is China's latest cargo spacecraft in the Tianzhou series, designed specifically to transport supplies and scientific equipment to support China's Tiangong space station. With a record-breaking payload capacity of 7.4 tons, Tianzhou-8 is currently the world's most capable cargo spacecraft, exceeding the US Dragon's 6-ton capacity. Its increased capacity allows it to carry essentials for long-duration space missions, including life support supplies for crews, scientific instruments, and unique items like the new lunar soil bricks, intended for lunar construction experiments. This mission is groundbreaking in that it also paves the way for China's future lunar exploration. The lunar soil bricks on board are made from simulated lunar materials, closely resembling the soil on the moon's surface. Scientists will study the bricks under the extreme conditions of space to assess their durability and suitability for potential construction on the moon. This testing is crucial as it will provide the data needed to determine if lunar resources could support permanent human habitats, reducing reliance on materials transported from Earth. Additionally, Tianzhou-8 represents China's growing efficiency in space logistics, as it marks the longest interval between resupply missions, 10 months since Tianzhou-7, demonstrating a leap in supply sustainability. With improved technology, China has adjusted its mission schedule from twice per year to a more sustainable average of 1 mission every 8 months, proving the Tianzhou series' capability in supporting long-term space station operations. Overall, Tianzhou-8 not only reinforces China's advanced cargo delivery technology, but also signals its forward-thinking approach to sustainable lunar exploration and station support. The Tianzhou-8 cargo spacecraft stands out among international cargo spacecraft for its exceptional payload capacity and advanced technology, capable of carrying up to 7.4 tons. Tianzhou-8 surpasses the US Dragon spacecraft, which has a maximum payload of 6 tons, and the Russian Progress spacecraft, with a capacity of just 2.6 tons. Unlike the reusable Dragon, which returns to Earth with cargo, Tianzhou-8 is designed to fully support China's Tiangong space station, delivering not only essentials for crew survival, but also scientific materials for experiments, such as simulated lunar soil bricks for lunar construction testing. In terms of mission frequency, Tianzhou's schedule has shifted from 2 launches per year to a more sustainable average of 1 mission every 8 months, extending the interval between resupplies to meet the long-term demands of the space station. This efficiency is due in part to the advanced design of Tianzhou-8, which maximizes its cargo space, allowing it to sustain station operations for up to 10 months, remarkable when compared to other cargo spacecraft. Additionally, Tianzhou-8 integrates China's cutting-edge propulsion and docking systems, positioning it as a global leader in autonomous cargo transport and a critical asset for China's ambitious space exploration plans, including future lunar and deep space missions. The launch of Tianzhou-8 has far-reaching implications for various industries, society, and the economy, marking a pivotal step in space logistics and China's growing role in space exploration. By demonstrating a superior payload capacity and the ability to sustain long-term missions, Tianzhou-8 strengthens China's capability for self-sufficient space operations. This advancement supports industries tied to space technology, such as aerospace manufacturing, robotics, and materials science, fueling demand for high-tech solutions in areas like autonomous docking, payload optimization, and advanced materials engineering. Economically, the development of Tianzhou-8 and the ongoing expansion of China's space program drive significant investment into high-tech sectors, encouraging innovation, job creation, and technological self-reliance. This influence trickles down into the civilian economy, as innovations in space-grade materials and energy systems often inspire applications in fields like telecommunications, renewable energy, and transportation. For instance, The research into lunar soil simulation for sustainable lunar construction could yield breakthroughs in materials that are lighter, stronger, and eco-friendly, which can eventually be used in construction on Earth. On a societal level, Tianzhou-8's mission boosts national pride and global recognition of China's space advancements. As China positions itself as a major player in space exploration, the public gains a renewed sense of inspiration, with young people especially encouraged to pursue careers in STEM fields, thereby building a highly skilled workforce for the future. The focus on sustainable lunar construction reflects China's long-term vision of using space resources, potentially laying the groundwork for future interplanetary mining industries. This could ultimately transform how we obtain resources, reshaping supply chains and reducing Earth-based resource constraints in the coming decades. Through Tianzhou-8, China is not only advancing its space ambitions, but also building a foundation for a broader economic impact that could influence technology, global resource dynamics, and environmental sustainability. The future of Tianzhou-8 and its successors looks promising as China continues to enhance its space capabilities and explore long-duration missions. With ongoing improvements in payload capacity, docking technology, and mission frequency, future Tianzhou cargo ships will likely support increasingly complex and prolonged missions, possibly including lunar and deep space projects. Tianzhou's advanced design may set a standard for international cargo spacecraft, encouraging global collaboration or competition in space logistics. Looking ahead, Tianzhou may also play a role in constructing a sustainable lunar base, using in-situ resource utilization (ISRU) strategies to build structures from local materials. As tested with the lunar soil bricks, this technology could become a cornerstone of future lunar or Mars missions, reducing dependency on Earth resources and paving the way for self-sustaining human settlements. In the long term, Tianzhou's developments could contribute to a space-based economy, facilitating mining, research stations, and perhaps even space tourism, positioning China as a leader in both technological innovation and space exploration. The Tianzhou-8 mission is a milestone in China's space program, set to launch soon to resupply the Tiangong space station with a record-breaking payload of 7.4 tons, surpassing other cargo spacecraft globally. Key mission highlights include delivering essential supplies for current and future crews and pioneering the use of lunar soil bricks for potential lunar construction, representing the first overlap between China's space station and lunar exploration projects. Tianzhou-8's enhanced capacity and extended mission intervals underscore China's advances in space logistics, boosting its self-sufficiency and global leadership in space technology. Additionally, the mission fuels economic growth in high-tech industries, inspires societal interest in STEM fields, and supports sustainable resource use for future space missions.